Alright, welcome to our lesson today on interpreting graphs of linear functions. So, in today's lesson, we will understand slopes, intercepts, domains, and range of a linear function, as well as graphing such functions using those terms. So, it looks like a lot to cover, but we'll go over them pretty quickly. So, starting with our little graph here of a temperature in a unknown location A. Okay, so we have time, the amount of hours in the x-axis and the temperature in the y-axis. Okay, so now we have to find a few things about this graph, namely the intercepts first. An intercept, all it is a place where something meets, right? It comes from pretty much English. It's luckily in math, it's the same definition. In a graph, there are two very important intercepts that we have to consider. The point where the graph touches the x-axis and the point where it touches the y-axis. It'll be right here and right there, right? Where the graph touches the x-axis and the y-axis, those are very, very important intercepts for us to pin down. And luckily, very easy to find for us too. So now let's take the horizontal intercept, or the x-intercept as an example. So if we look at the graph, we quickly notice that right here, this is where our line touches the x-intercept. So x-intercept right there. And similarly, this point is where our line touches the y-intercept, or the y-axis, we call the y-intercept, right? And then now to represent this as a coordinate system, we have x equals to 4 and y equals to 0, right? That's all it is. So you can think of the place where we touch the x-axis is, well, when y equals to 0, right? So along this line right here, when the moment y equals to 0, then yeah, of course, it's going to be the x-axis. So when y is 0, what is x? So if we look here, if y is 0, x is 4. And similarly, when x is 0, so when x reaches 0 now, where it on the line is y. So in this case, when x is 0, we're looking at this line right here. We notice that it touches the y-axis right here. And we notice that we're starting at 0 up here and then negative 10 down here in between those 2 points. So this point in between the 0 and the negative 10 will be negative 5, which means that when x is 0, y will touch negative 5. Okay, so that's all it is. All the intercepts are is where it touches on the graph, right? And now from our last lesson, we learned that the rate of change, or the slope of a graph, is the rise over run. Okay, so rise over run, which also means the change of y over the change of x. And all we have to do is pick 2 points on the graph and kind of relate them to each other, right? How much is the graph changing between those 2 points? And that's how I find the slope, right? And in order to find a changing y and changing x, we can just use the 2 intercepts, right? Those 2 are very, very easy to work with because we have a 0 in each of them, which means that there isn't really a lot of calculations we have to do. We just have to put it in a fraction, right? So when the x-intercept is 4, 0, the y-intercept is 0, negative 5. So at the x-intercept, right, x equals to 4, while y equals to 0, and the y-intercept, x equals to 0, while y equals to 5. So now all we are doing here to find a changing y is comparing this y here with this y here. So the changing y now will just be 0 minus negative 5 over this x and then this x. So over 4 minus 0. Alright, so all that is just 5 over 4. Alright, so all the slope is telling us is how much change is happening between 2 points on the graph. And once again, we can easily do any points we want. We could have done the change of, say, here and here. We could have found the change between those 2 points. But those are kind of weird numbers to work with. Like this is, what is this? Like x is 10.5 and y is 7-ish. And this point here is x is 7.5, y is, that's like 2.5-ish, right? So those are just like decimals and not whole numbers to work with. But if we can find 2 points, that is the x-intercept, so where this line touches the x-axis, and the y-intercept, where this line touches the y-axis, it is just a really easy calculation because we have a 0 in each of them. Okay, so let's do some examples here. So we have this graph of volumes of gas in a scooter. Right? So let's do domain and range first. Right? Those are from our last lesson. So domain is pretty much all the x values of a graph. And as you can see, this graph only goes from here to here. So the x values will just be from this point to this point. So from 0 all the way to 200. I don't know why this is t here. That's not time. It should be distance. Let's just do d here. So 0, or the d, the distance, is between 0 and 200, right? And now the range, right, is the y values. So from, again, the graph goes from here to here. So the y values of here to here, which is from 8 all the way to 0. So 0 smaller than v, smaller than 8. Right? So the y values, or the volume, is between 0 and 8. So you can see from here to here. And the x value, which is the distance value, goes from 0 to 200, which is from here to here. I guess that here to here are pretty much the same thing. Okay, anyways, now let's find the slope's intercept. So let's find the intercept first, because slope can come later. So now, where does this graph, or where does this line touch the x-axis? We can see visually on the graph, it touches the x-axis right here, right? Or when y equals to 0, where is it touching the x-axis? So the x-intercept, right, is what is x when y equals to 0? And as you can see here visually on this graph, when y equals to 0, x touches at 200. How about the y-intercept? Where does this graph touch the y-axis when x is 0, right? As we can see here, right there at 8, just like that. So now what's the slope? So again, that's the rise over run, or changing y over changing x. Like as mentioned earlier, we can pick any 2 points we want. You can do like this point here, find a difference between those 2 points. Or we can use our intercepts, right? This is a very nice easy calculation because we got zeros in the coordinates. Let's do, doesn't really matter which one we subtract with which one. So let's do x-intercept subtracted by y-intercept. So the rise is the y values. So the y value of the x-intercept is 0. The y value of the y-intercept is 8. And the x value of the x-intercept is 200 minus the 0 for the y-intercept. And it's negative 8 over 200. We'll just quickly reduce that to get negative 1 over 25. Right? And that is the slope of this graph. Pretty much it. Okay, so now let's reverse everything and sketch a graph of this fella right here. So once again, all we need to do is to find the 2 intercepts and connect the dots, right? So we know the x-intercept occurs when the y equals to 0. Okay, so x-intercept when y equals to 0, and the y-intercept happens when x equals to 0. Right? So let's just plug into the function and see what happens. So when y is 0, okay, so 0 equals to negative 2x plus 7. We subtract 7 on both sides to get negative 7 equals to negative 2x. We divide both sides by negative 2. We get 7 over 2. Right? So that is the x-intercept. And now the y-intercept, this one's a bit easier. Right? So y equals to negative 2 times 0 plus 7, which is just 7. Right? Which means that the 2 points of interest is the x-intercept, which is 7 over 2 and 0, and the y-intercept, which is 0 and 7. Okay, so now on the graph here, right, we got 2, 4, 6, 8, 2. Okay, so now for the x-intercept, we know that this graph touches the x-axis at 7 over 2, which is 3.5. So it will be somewhere right here. And we know that it touches the y-axis at 7. So it'll be actually right here-ish. Ooh, slightly extend our little line split. All I have to do is connect the dots. That's pretty much it. That's how I draw a function, right? Pick 2 points, connect the lines, and that's pretty much it. And now, obviously, the graph doesn't just end between the intercepts. It will keep going infinitely. So we actually have to extend the graph past our points here, right? But that's pretty much how we draw a graph, right? This only works for linear graphs, because with linears, all linear graphs is essentially a straight line. So if you just find 2 points, we can draw a line and however we want. And of course, the easiest way to find 2 points is if x is 0 and y is 0. That means that we're finding the 2 intercepts. Okay, so with all being said, here's some practice questions. Pause the video here and try them yourselves. Okay, so hope you had some time to do those questions, and let's get to it then. So, sketch a graph of 4x minus 3. So, once again, we find the x-intercept and the y-intercept. So, x-intercept is y is 0, y-intercept is when x is 0, okay? So now when y is 0, that 0 equals to 4x minus 3. We add 3 to both sides, divide by 4 on both sides. X equals to 3 over 4, which means that our x-intercept is 3 over 4 comma 0, right? Because when y is 0, x is 3 over 4. y-intercept is 4 times 0 minus 3, which is just 0 minus 3, which is negative 3. So the y-intercept is 0 comma negative 3. Okay, all I have to do is to do a fun little game of connect the dots. That's 2, negative 4, that's 2, 4, okay, and 6. So, first point, 3 over 4 comma 0. That will be right here. And then that would be right here, just before 1. And then 0 comma negative 3 will be down here. And we just draw a line to connect the dots like that. Okay, again, that's an artist error here. Connect the dots here, connect the dots here. Okay, and that's pretty much it. That's how you draw a graph. Right? Nice and simple. You pick two dots, the two intercepts, and then just connect them. Next, we got a graph of cost of publishing yearbooks and how many books can we print with $4,200. Right? So now with this question, there are two ways to go about this. So the first is if you were to grab a ruler and you draw a line to connect all those dots together, then we can say, okay, well, looking at 4,200, it should be around here-ish. And if we look down, that is around, say, 180-ish books, right? That's like an estimate, but we don't really know how accurate that is. So alternatively, what we can do is construct an equation. So here's how we do it. We first find the slope. So unfortunately, we don't really know what the x-intercept is, but at least we have the y-intercept, right? We know this dot right here, because it is going up by 1,000 for every 2 squares, we can reasonably conclude that this right here is 500. So one of our points right here, but the y-intercept is 0, 500. And then we can just take any point we want. We can take the closest point. So in this point here, x is 50 and y is 150, or 1500 rather, sorry. Okay, and then we just do our classic rise over run. So the slope is rise over run. So the rise is the changing y value. So we're changing from 1500 to 500. And the x is 50 minus 0, right? So all we're doing here is figuring out the rise here, which is 1500 minus 500. And then the run here, which is 50 minus 0. That is 1k over 50, which is 20, right? So that's our slope, 20. Okay, so what the slope is telling us is for every single yearbook that we publish, it will cost $20. So that's all it's telling us. So now what we can do is to construct an equation. So the cost, right? We know that for every single yearbook, it goes up by 20. So every single yearbook, which is n, it goes up by 20, right? Just like that. And then we also know the initial cost is 500, right? Because right here, we start at 500. So to make the equation, we have C equals to 20n plus 500, right? So with that being said, how many books can we publish was 4,200? So all you're saying is, now if the cost is 4,200, what's n? So how many books can we publish? Right now this becomes a good old algebra question. Fine, isolate for the variable. Subtract both sides by 500. We get 3,700 equals to 20n. Divide everything by 20. We get n equals to 185. Right? So from this, we can conclude that with 4,200, we can buy 185 yearbooks. Right? And as you can see, this is the reason why we actually care about finding the slopes. Because with the slope, we can then conclude an equation like this to help us figure out graphs where there's no line to be connected, right? And the reason for why there isn't a line here is because, well, we just cannot have half a yearbook, right? So for the cost, obviously we can have $1.17. But with a yearbook, we cannot just sell, if we look somewhere here, 57.7 yearbooks, right? So in this case, the lines are not connected, so we cannot just say, okay, well, we can draw a line here and then kind of guess 4,200 is here and then compare it to here, right? In this case, we'll need to find the slope, set up an equation like this, and then figure it out from there. So yeah, a lot of terms this lesson, but it's very, very useful for if you want to draw any type of graph that's linear. So with that being said, keep practicing and stay hydrated.